Alright, so you need to take notes over titrations. We're going to do some definitions and I will give you the formula. And then we will do the first two examples of your titration worksheet so that you can complete that in order to do the lab that we're going to do tomorrow. So titrations are the controlled addition and measurement of the amount of a solution of known concentration required to react completely with a measured amount of a solution of unknown concentration. So these are all acid-base reactions, and you've got one known concentration and one unknown concentration. So make sure to write down that definition. Also, when we do this lab, we're going to be talking about something called the endpoint. And the endpoint is the point at which an indicator changes colors. So to do the titration calculations, because you will have a known concentration and an unknown concentration, we're going to have to solve for the unknown. So the formula for these calculations is very similar to the M1V1 equals M2V2. However, this one is MA times VA times CB equals MB times VB times CA. So the A's stand for acid and the B's stand for base. MA would be the molarity of the acid. VA is going to be volume of the acid. And CB is going to be coefficient of the base. So notice it goes acid, acid, base. Then on the other side it's base, base, acid. So it's molarity of the base volume of base and coefficient of acid. Alright, so that is the formula you will be using, and we are going to do this example. So write down this example. A 25 milliliter solution of H2SO4 is completely neutralized by 18 milliliters of 1 molar NaOH using phenolphthalein as an indicator, and that's the indicator we're going to use in the lab. What is the concentration of H2SO4? So your equation is MAVACB equals MBVBCA. So those coefficients come from the balanced equation. So we need to write the balanced neutralization equation. So you've got acid plus base gives you salt and water. Your acid is H2SO4. Your base is NaOH. It will always give you water and a salt. Na2SO4. Alright, so acid plus base gives you salt and water. You need to balance it first with a 2 here and a 2 here. Okay, now that it is balanced, you have all of the coefficients that you need. So, for example, H2SO4, you just have one of them, so the coefficient is 1. And your base, you have 2 of them, so the coefficient is 2. Alright, now that you have that balanced equation written out, you can plug everything into your equation. So molarity of the acid, if you look, it gives you volume of the acid, but it does not give you molarity. So molarity of the acid is your X, that's your unknown. Volume of the acid, it says 25 milliliters of a solution of H2SO4, which is your acid. So this would be your VA, 25 milliliters. And next part of the equation is coefficient of the base. So you have to look at your balanced equation. The coefficient of your base is 2. So molarity of the acid, volume of the acid, coefficient of the base equals molarity of the base. So reading in the example, it is completely neutralized by 18 milliliters of 1.0 molar NaOH. So that is your concentration, that's your molarity of the base, 1.0. So that's your MB value. And volume of the base, 18 milliliters, that's your VB. And last part of the equation is coefficient of the acid. Your acid is H2SO4 and the coefficient is 1. So if you multiply both sides, this would be X times 25 times 2 would be 50X equals 1 times 18 times 1, which is 18. Get X by itself, divide both sides by 50. X equals 0.36. And we got to look at what we are solving for. We were solving for MA, so 0.36 is the molarity of the acid. And that's your final answer. Alright, so we're going to do the first 2 examples of the titration calculation worksheet that you got. So number 1 is 0.53 molar hydrochloric acid required 76.02 milliliters of 3.1 molar aluminum hydroxide. So your equation is MaVaCb equals MbVbCa. So in order to get your coefficients, you need a balanced equation. So a hydroic acid comes from an "ide" ending. So it's hydrogen chloride. And your base is aluminum hydroxide. Aluminum is a +3. Hydroxide is a -1, so it's going to be AlOH3. Acid plus base always makes salt and water. Your salt will be AlCl3. To balance it, add your coefficients, so you need a 3 and a 3. Okay, now we're ready to plug in numbers to our equation. So, first part of the equation is molarity of the acid. 0.53 molar hydrochloric acid right there. That's your Ma. Ma times Va, so it doesn't give you a volume of acid. It gives you a volume, but it says it's 76.02 milliliters of aluminum hydroxide, so that's of your base. So we don't know volume of acid, so that's our X. And next part is coefficient of the base. Your base is AlOH3. The coefficient, you just have one of them, because you don't have a number in front. So it equals molarity of the base, which is 3.1 molar, volume of the base, which is 76.02, and coefficient of the acid from your equation, 3HCl, so 3 is your coefficient. Multiply these out, you would get 0.53x equals 706.986. Get x by itself, so divide both sides by 0.53. X equals 1334 if you round it up. So 1,334. Your X is your volume of the acid, and so volume is measured in milliliters. So that's how many milliliters you need of HCl. Problem number 2 says 11.2 milliliters sulfuric acid required 25.4 milliliters of 0.49 molar sodium hydroxide. So again, you are using MaVaCb equals MbVbCa. Alright, in order to get your coefficients, you need a balanced equation. So this is an sulfuric acid, it's just an ic acid, so that means it comes from an 8 ending. So sulfate, and SO4 is a -2 charge, so that means you need 2 hydrogens. H2SO4, sulfuric acid, and sodium hydroxide. Acid plus base makes water and salt. To balance it, you need a 2 and a 2. And then you can start plugging in your numbers. Molarity of the acid, we don't know. So that is your X. Volume of the acid, it says 11.2 milliliters of sulfuric acid. So 11.2 is your volume. And coefficient of the base. Your base is NaOH, your coefficient there is 2. Molarity of the base. So it required 25.4 milliliters of 0.49 molar sodium hydroxide. So those are all the numbers to go with your base. The molarity is 0.49. And the volume is 25.4. Last part of your equation is coefficient of the acid. You only have 1 there, so the coefficient is 1. So multiply both sides. This would be 22.4x equals 12.446. You want x by itself, so divide both sides by 22.4. X equals 0.556. And x, what we solved for was molarity of the acid, so it's 0.556 molar, and the acid you used was H2SO4. So that's your final answer. So for all these problems, you need to first get a balanced equation so that you can get your coefficients, and then your next step is to just plug all the numbers in to the equation, and then you solve for x.